Ethernet LAN switching for the CCNA. So, Ethernet, which is Ethernet, LAN, which is local area network, and switching, which is layer 2 addressing from the OSI layer. So, LAN. A LAN is a local area network. The way it operates is like this. So, say we have like a home network, right, with like laptops, cables, computers, printers, whatever, right? And they're all connected with like a switch, right? Like in an office or something in a building. This is a LAN. It is a local area network. It is network in a small area, right? And what differentiates this from a LAN is that a LAN is basically a WAN is basically a bunch of LANs mixed together. Like that's a wide area network, but that's a topic for another day. For now, you just need to know LAN, right? Local area network. Simple enough. So switches are based off of MAC addresses. That's how they address, right, each of these things. So like each of these we can say like a house, right? Say that this house wants to send a letter to this house. How would it do that? It would do that through like an address, right? And the address we'd use is a MAC address. MAC stands for Medium Access Control. It is a burned-in address. That means that the manufacturer, gives it to it, right? It consists of 6 bytes or 48 bits, and it is hexadecimal, right? And this is an example, right? If you don't know what hexadecimal is, here's a quick chart. I'm not going to cover it for the sake of time, but you do need to know this for the CCNA. So just kind of memorize this table for the greater good. Okay. Okay. So the first 3 bytes are the organization unique identifier, or the OUI, and the last 3 bytes are unique to each device, right? So the first 3 bytes are assigned from like the organization, last 3 are unique to the device, and everything else is just, just depends on how they burn in it. Okay, so how would a switch, right? How would a switch like handle that information, right? If like say there are a bunch of these, we can of course manually log them, right, into the switch saying, okay, this is this MAC address and this is that MAC address, right? But there should be a better way, and that better way is dynamic MAC addressing, right? This is where the switch learns and logs MAC addresses to ports dynamically. It is automatically enabled on all Cisco switches. It removes, like, it logs MAC addresses to ports, and then if that MAC address is inactive for 5 minutes, it removes it, right? So if a switch doesn't know which port a MAC address is in, right? Say the switch like doesn't know where, like, who this person is, it's gonna flood out a message to every single device and say, hey, if you're this MAC address, let me know so that I can log you and put you here, right? If it's requested. Um, Another thing for frames, right? When I'm talking about frame, I'm talking about here. So remember the OSI model, and where the protocol data unit of frame is. So a data link layer, layer 2, right? And this is a frame. So the parts that we're going to be looking for today, or which is parts that are dealing with MAC addresses, are the header and the trailer, the layer 2 header and the layer 2 trailer. And this is how it would look like: preamble, start frame delimiter, destination, source, type, and that's the data in the middle, and then the frame check sequence, right? And you should know all of these. Just quickly read all of this, right? It's pretty simple, the destination, source, address, the max, and everything else. It does make a decent amount of sense. You should know the minimum Ethernet payload is 46 bytes. Frame should be a minimum of 46 bytes. 46 bytes. Okay. So if it's not 46 bytes, it'll add like zeros, zeros, zeros at the end of it, just like for padding bytes. Padding. Padding bytes. Okay. Anyway, so that's for MAC addresses, right? Um, another common scenario that would happen, right? Say you have like this, a switch connected to 2 computers, right, on 2 different ports. is that say that the computers have each other's IP addresses, but they don't know each other's MAC addresses, right? And IP addresses we're going to cover probably tomorrow. If we have the if we have the layer 3 address and we want to find the layer 2 address or the MAC address, right? We'd use ARP, our address resolution protocol. And ARP basically broadcasts to all hosts on the network, and the broadcast address is all Fs. This is the broadcast MAC address, right? And then whoever has the MAC address, that's like the IP address, right? They're going to say, okay, I have this IP. Let me send my MAC. So it's going to unicast it, right, to the switch and inform the switch that this is me, you know? Um, and then there are commands for it, show ARP, clear IP ARP, and we'll discuss those shortly. And then the last thing I want to talk about today was ping. And you've probably heard of ping, and ping is basically just a utility to test reachability with IP addresses, which again we're going to cover tomorrow. So you type basically ping IP address, and it would ping, and it consists of an ICMP echo request and a reply. And oftentimes, when you initially do a ping on a new network or a network that hasn't been used that much yet, it will first perform ARP because it first needs to find the MAC address, and then it will finish out with the echo request and echo reply. So Jeremy's IT lab has a great Cisco packet tracer lab that he's made available to the public. So let's quickly go through it. So we have computers, switches, and computers. So this would be a local area network, right? Let's go into one of the computers. Let's open another computer. So we have these two computers that are supposedly open. Let's say this computer, I want to get its IP. This is IP. I'm just going to quickly copy it. And in this other computer, I'm going to go to the command prompt and I'm going to ping it. I'm going to do ping and then the IP address, and it pings wonderfully. So that means that we do have connection. So let's see what happened on the switch, right? So let's get our console cable. Let's put it in the console port and then go on our laptop and then terminal, and then I'm pretty sure automatically figures out the port that's supposed to go to, and then now we're in the switch. Okay, let's do enable. And now let's look for some commands. So let's look at the MAC address. So show MAC address table. Yeah, let's just show the MAC address table. So it shows us that it has two MAC addresses saved. Both of them are dynamic, and the interfaces that they're saved on. So fast Ethernet 01, that's PC1, so it has PC1's MAC address, and it has gigabyte 01, and that's this MAC address, right? And this MAC address would be PC4 because we pinged it. So it basically says if someone's trying to access PC4, then send whatever the messages, whatever it is, like the data, send it through gigabit Ethernet 01, right? Because that's the destination to go there. Automatically, this will clear after 5 minutes. But if, say, you really hate it and you want to clear it now, you can do clear MAC address table dynamic, and it clears everything. So now if we show, by the way, you can do the up arrow to go back to commands, like to redo them. We'll see that it's completely empty. And if we try to ping again, let's go PC1, terminal, oh wait, not terminal, PC1, command prompt, and let's ping the same thing, and then we check this one again and we do the show again. We're gonna see that it comes back because we did it again. Amazing. And that's about it for the switches. If this was a router, we could use the show ARP and the clear IP ARP command, right? Over here, show ARP, clear IP ARP, and it'll basically just show us the same thing, but for IP addresses, and not like it'll show us the IP addresses mapped to the MAC addresses, right? But switches don't deal with IPs, they only deal with layer 2. And I think that is everything that I want to cover today. Thank you.